Dr. Anand. Today we are going to discuss about a very important topic in neural network, which is activation function. This video is divided into three parts. First, I am going to discuss about introduction to activation function. Second, there are different types of activation function and I am going to explain each and every types. And third is when and where to use which type of activation function. एक्टिवेशन फंक्शन को जानने से पहले वी हैव टू नो व्हाट इज ह्यूमन परसेप्ट्रॉन मॉडल. ह्यूमन परसेप्ट्रॉन मॉडल is a simplified version of artificial neural network which represents biological neuron in our brain. Suppose for example a mosquito sits on my hand, then it bites. So what will happen? And information will go from my hand to my brain and my brain neuron will work, and then it will give signal to my other hand to slap on it, right? So in a similar fashion a neuron works. Say this is a neuron in our human brain. This is dendrite which gets the signal. This cell body processes it and then it gives the output through the axon. Artificial neural network mimics the function of neuron in our brain. सिमिलर वे में जैसे ये ह्यूमन परसेप्ट्रॉन मॉडल है, सेम वे में न्यूरल नेटवर्क इज डिजाइंड. दिस न्यूरल नेटवर्क हैज फोर पार्ट्स. वन इज इनपुट, वेटेड सम, बायस एंड एक्टिवेशन फंक्शन. पहले क्या होता है, जो मॉस्किटो यहाँ पे आया था दैट इज प्रोवाइडिंग अ इनपुट सिग्नल टू आवर ब्रेन. सो सिमिलरली दिस इनपुट सिग्नल्स आर कमिंग and this cell body is represented by weighted sum. इसका मतलब जो इनपुट आ रहा है उसको पहले इकट्ठा करेंगे. And then there is one more thing which is bias. Bias is kind of unwanted signal and then it goes to activation function. Now coming to it, activation function is an important part of neural network. Activation function is a mathematical operation or a function which is applied to the output of each neuron and it decides whether a neuron will be activated or not. Now first of all let us understand why we need an activation function. Now if y is represented in output, so y is actually represented as this plus this, which actually means x1 and then there is one this weight, then weight 2 like this way, weight n. So it means that x1 into w1 plus x2 into w2. Then in this way we are adding other weights and then comes the bias. B is bias, which is an unwanted signal. So now how we are going to represent this activation function? It's like that this y is coming from here, right? And then an activation function is acting on this y. So f of y will be z, which is the final output. So this output is actually z and this is our activation function. Thus it says that this f is a mathematical operation which is acting on these things to give an output z, and this function determines whether an neuron will be activated or not. Now first of all coming to it, why we need this activation function. We have to know what is the purpose of this activation function. This activation function actually brings non-linearity to the output of the neuron. Now as I have already mentioned that there are different types of activation function, so for different purposes we are using different types of activation function. So we have to know what activation function should I choose. So it depends on two things. First of all, it depends on the types of the problem we are solving, and second is that is the complexity of the problem or the complexity of the neural network. Based on these two things we will define like which activation function is to be used for a particular scenario. So in my upcoming video I am going to talk about different types of activation function.